Great. Thank you very much. And thank you all for attending today. So I'm going to be talking about Git and GitHub in particular for most of this talk. But before I do that, I want to take a step back about these are technology and their tools and they're a particular choice that somebody could make. I want to talk just a little bit about like, why do I even bother to do this in the first place? And so what I really care about, like deep down, what the actual learning outcome I'm thinking about here is really about teaching reproducible workflows. So modern statistics is fundamentally a computational discipline. You'd be pretty unique as a statistician if you never touched a computer for your daily work. And so in thinking about that, we need to think about when we're producing sort of computational artifacts, code, analysis, and that kind of thing, how do we ensure that those things are reproducible? And then how do we train our students that when they do their work, that their work is also reproducible? And in talking about all of this, it's also really easy to get confused about what do I mean by reproducible versus replicable, all these kinds of things. And so I very often like to refer to this paper by a group out of Johns Hopkins where they put together this really nice sort of cartoon explanation of what does the scientific process look like. You have a population and a hypothesis or a question, you go through these kinds of things. And each of these little icons sort of represents a different step in the scientific method. And when I'm talking about reproducible, we're talking about the barest minimum possible thing in terms of sort of verifying the scientific method. So in this thing, on the left-hand side, we have sort of one approach, one analysis, one experiment. And then all that we're changing is the person who's running the analysis. We're not changing anything else. We're not changing the data. We're not changing the code. We're not changing anything else. And really, if we think about sort of science as an enterprise, this is the bare minimum that we should expect. Like, we should be able to do this. It shouldn't be that hard. But the problem is it is kind of hard. It's not trivial. This isn't what we should settle for. There's a lot more we can think about. The larger picture, replicable work, repeating things, all that kind of stuff. But what we want to do is at least not sort of hamstring ourselves before we even start on this endeavor. So this is the kind of thing that I want to think about in my teaching when I'm training new statisticians about, okay, what are the tools that we can give them that enable them to make their work as reproducible as possible, given sort of the constraints that we have. And this ecosystem is evolving and it's much better than it used to be, but a lot of these ideas are not new. We're just trying to take up what's best out there and run with it as much as possible. So reproducibility in practice, I show this to my students in terms of what we do. And again, part of this is getting them to buy in. Like, why is this important? What happens if your collaborator sends you an updated data file? Can you just rerun the document and get the new results? Or do you have to rerun everything and recreate all your figures and do all of that kind of stuff? So again, not all of these correspond exactly to the figure I had before, but these are sort of reproducibility in the real world. What are the kinds of concerns that you should have and you should be thinking about as you're working through something? So for my purposes, I think there's sort of three key pieces in the education and the tooling that I use. And you can swap out a lot of these tools to something else, but there's sort of the three key parts. The first is scriptability. So basically what that means is anything that we're doing, we're documenting it with code in some way. And the difference between this is if I'm analyzing a data set or I'm modifying a data set, I'm using a programming language to do that, where I'm documenting every change that I make versus opening that file up in Excel and changing some of the cells. There's no auditability, there's no tracking those changes, that kind of thing. It's quite difficult. The next little bit is literate programming. So we do analyses, we write up sort of complicated open-ended type things. And really it's kind of important to couple the code and the output with the narrative. We want all of that together. It's easier to maintain if they're all in the same place. And if you have one document that has the figures and the code and everything else as we go. So in particular in our course, we use R Markdown for that because it's fairly lightweight and it's quick to get the students up and running with it. And then the final piece of the puzzle for me is version control. So just being able to track changes over time. Everything we're working with are just text documents, so they're very natural to work with sort of traditional version control systems. But again, you could swap R for Python here, Jupyter Notebooks for R Markdown, and Subversion or Mercurial for Git and GitHub, and you'd still get most of the benefit. All of these things are sort of foundational to this whole idea of reproducible research, and hopefully it's not too controversial sort of a position to stake out in all of this. So what I want to talk about then is the particular ecosystem I'm using and what are the advantages and disadvantages we have there. So for context, I'm the course organizer for a large course on statistical programming. This is a required MSc course for all of our statistics MSc students, and we also get a fair number of applied math students and operations research students as well. And it's roughly about 200 students each year. So just shy of 200 last year and just shy of 200 this year. It's 100% coursework. We have multiple marked assignments, and we do a sort of a combination of individual assessments and team-based assessments throughout the semester. In terms of using the tools that I just talked about, whenever we give assignments out, it's not just sort of sending out a PDF and saying, do something, and we'll hope for the best. We do it in a very sort of purposeful and structured way. So we give them an instruction document. We give them a templated RMD document, so an R Markdown document that says, for exercise 1, put your answer here, put your code in this particular code chunk, do that kind of thing. And very often we're distributing them the data set or some support functions or other script files and that kind of things. And all of these things need to go out. Trying to do this in an ad hoc fashion, sending the students a zip file works. You can get it to go, but it often fails in spectacular ways, particularly in a larger course. That tail is really long. Somebody will find a way to mangle something in a way you didn't expect. We also then need to collect all of this work at the end. So I don't really care about the instructions or the templates, or sorry, the data files anymore, but I do need to collect the templated RMD file. So very often I want to ensure reproducibility is something that we're assessing on the assignment. So I want the raw file that I can then run myself to make sure that I get the same output. Or in some cases, just to make my life easier, I want the rendered output, an HTML or a PDF file or something else like that. I'm sure people have done things like this in their courses. It's very common. You send a file out with a particular file name and a particular structure, and you get back 18 different versions of the naming things. Students add their name to it, or they do something else. They mangle the file structure in some way. So that's also not trivial to do. And so what I want to talk a little bit about this particular ecosystem with Git and GitHub as a way of making that whole process much smoother, much more sort of efficient to do this kind of thing at scale in a large programming focused course. So we use GitHub. They have excellent sort of educational benefits and support. The way that we organize this is using something called the GitHub organization. So this is something that you can create for free on GitHub, and organizations then have members, and those organizations also own repositories, which is where the students' code goes. We add all of our students in the course to the organization, and GitHub supports doing that anonymously. So their membership in that organization is not disclosed. So they have a very sort of privacy first policy and approach. For any given assignment, we're then able to set up sort of a template repo. So all of those files I just described before, we put those in. We use a normal sort of Git workflow to put those together. I can share them with my tutors to look over and get feedback ahead of time. We can make changes. And then when it's ready to give out to the students, we take those and we copy them over so that every student gets their own private repository for that assignment in the case of an individual assignment, or we give one repository per team. And so GitHub also has good support for permissions and teams within all of this so that you give access to only one group of people for a particular thing, that kind of stuff. All of this is very automatable. GitHub has a fantastic API that you can do it all on the website by clicking a bunch of buttons, but that gets old really quickly. And so you can interact with it programmatically. And so one of the things I spent a lot of time over the last couple of years is writing a package in R called GH class that automates a bunch of these actions. And I'll talk about what that looks like in a little bit. So the organization for my course last year looked something like this. I've cut off any sort of the identifiable information about the students, so the repos. You can see the homework 0, 1, and 2 are pinned repositories that are those templates that I created. We also do exercises in class. I can write the code up and then I can post it there for them to look at and work with later on. The other thing to note here is that over the course of a 10-week semester or 11-week semester, we ended up with almost 800 repositories created, 190 teams, 194 people in it. All of this is great, it's really powerful, but doing all of that by hand is not viable for something at this scale. It's just too much time to do. So this is where the automation type stuff becomes very useful, very important. And if you haven't seen what a GitHub repository looks like, this is just sort of the contents of it. So that README is the instruction file I mentioned. It tells them what they're gonna need to do for that assignment. I can include images or pictures, that kind of thing. The RMD is just the template that I want them to enter in things. And then I'll talk a little bit later about what those workflow files are at the top and what those let us do. But the point is, I can go in, I can edit this stuff, and then it becomes very easy to distribute to a large number of students fairly quickly. So this package I mentioned briefly, it's just designed to interface with the GitHub API and basically just to do these repeated tasks over and over again as efficiently as possible. So that's things like repository creation, repository mirroring, updating things, collecting the assignments at the end, dealing with your organization, so inviting students, removing students, inviting them to teams, all of that kind of stuff. Also, since we're using Git, one of the nice things is we can keep track of who made what change when. So that's very useful for accountability of, okay, here's a team of 4 people, who made how many commits. That's not super strong information, but it is very useful to know something about team dynamics and combine with sort of other feedback that you might get. There's a website, you can take a look at this. I'll also point you later on to a workshop myself and my wife ran earlier this summer that goes into this in a lot more detail. But the point is, it's trying to automate as many of these sort of common tasks as possible to make it interact with GitHub doable as sort of a classroom management system. So just very briefly, I'm not going to get into the details here, but okay, if I wanted to create a team assignment, here's a function call. I'm doing it in a particular organization called ghclass-demo. I'm creating 2 different repositories with 4 different users and 2 different teams. And then I'm providing a template where all that information is getting pulled in from. So all of those files that I had in that template get populated into the students' repository. And you can see in the results down below that there's a variety of steps that are involved in this. So if you're trying to do it by hand, it would be going through 2 or 3 or 4 steps per repository to get any of this done. Collecting it is also really straightforward. We can go out and clone all the repositories off of GitHub. So I can go out and say, give me all the repositories that start with homework 01, download them, and then I'll have a local copy of each of those things so I can go through and mark them, or I can feed them into an auto feedback system or do something else with them. It gets very quick and easy to pull that together. And then what I mentioned before, contributor statistics. So these are 2 different teams repos, and I can see which user contributed how much. And again, I don't really care how many times they committed, but if somebody's on the tail end and they only committed once, that might be an indication that they're not contributing much to their team. And if that's combined with things like peer evaluations, I might know that there's a problem there and I can intervene as an instructor. So this is sort of run-of-the-mill stuff. One of the other things that I'm really excited about and interested in is what else we can do with this larger ecosystem. So GitHub recently announced this tool called GitHub Actions, which allows you to automate actions and tasks whenever the student does something with the repository. So most often what this means is when students send their code back to GitHub, they push in the Git vernacular, you can then trigger something to run. And so for me, I'm very interested in not necessarily providing automatic feedback about sort of whether they're right or wrong about an answer, but more about process. So can I check whether the code they submitted is reproducible? Does it run? Can I check, does it follow the style guide that we specified? Can I check that it doesn't have any files or misnamed files that I don't want? All of those kinds of things. And so what we're seeing here in this picture of this repository with those little flags at the top in red and green are the various automatic actions I'm running on that repository every time the student pushes and telling them whether something went wrong or not. What the students can then do is click on those to get more feedback about each of their pushes. And in particular, they get text output that shows the actual thing that happened. So in this case, this is a little bit more of a complicated check, but what it's doing is it's looking at the structure of the document they submitted and saying, did you provide an answer or not? And so in this case, it's saying section 1, task 1 implementation has a code chunk named FizzBuzz, which has not been modified. So it's telling them, we provided you some sample code, you didn't change it, you probably meant to do that, why don't you go and fix that? And so there's a way of specifying sort of from the template what the document should look like and then comparing their submission to that and then giving them some feedback. And again, it's not checking whether they're right or wrong, but it's saying, you forgot to do something, you should do that. And it's sort of disintermediating myself and the tutors from that process to make things move along a lot faster. And as I said, there's a variety of other kinds of automated tasks you can do here. Anything that you can sort of script in R or Shell or any programming language you want, you can do, and you can provide feedback to the students on their repositories, either on a schedule or whenever they do a particular action or that kind of thing. And it's an incredibly powerful tool to play around with that you get sort of for free by buying into this ecosystem. I've got a variety of sort of related ongoing work myself and then with some other collaborators. So one of the other things that we're trying to do within GH class is peer evaluation. So again, this is a useful tool for larger courses. And once we have all of these files from the students, we can move them around in any way that we like. So if we want to sort of take the code that students submit, rearrange it, and then send it out to other students so they could look at it and try to run it themselves, we can automate that whole process. And so there's some work by Mina and Therese putting that together within the package that lets you do that. Again, just leveraging the GitHub API to automate that sort of process through lower level actions. And then I've also been spending a lot of time this summer in anticipation of this online semester providing building tools around this automatic feedback process using GitHub Actions and other things. So a couple other R packages that do this. So checklist is about sort of simple ways of writing checks for student submitted work. So checking allowed files, checking packages they use, libraries they use, that kind of thing, checking for structure. And then this parse RMD is, if you're not familiar with them, our Markdown documents are semi-structured text documents. So this package lets us parse those, pull the pieces out, so then we can then examine them to say what happened in this particular code chunk, that kind of thing. So those are all works in progress, but I think there's a lot that's possible there with that tooling. I will just flash this briefly. The last slide has a link to this overall set of slides, but here's some resources on Git and GitHub, particularly sort of with a flavor towards statistics and the R ecosystem. In particular, I'll point out the sort of fourth item. This is a draft paper that myself and a number of other people have put together. But what it includes is sort of 4 different narratives of people who've included Git and GitHub in their statistics courses and how they've gone about doing that. And that's everything from sort of introductory statistics courses all the way through master's level courses. Talking about sort of what's commonly done, what's not. But I think that's a very useful thing. And so that article is linked on arXiv right now to take a look at if you're interested. So I will leave it there and take some questions.
Thank you.
So the bit.ly link here is, if you're interested in the slides, they're all there and you can follow the links.
Thank you very much, Colin. That was a fantastic talk. And I think one of the comments in the chat actually says it all. This looks awesome, and it really, really does. So we've got a couple of questions here for you. So the first one up, what's your fallback when GitHub falls over or revokes educational accounts at short notice? Have you thought about that? Is that likely to happen?
So I don't think it's that likely to happen. So if you're not aware, GitHub was purchased by Microsoft in the last couple of years. And it sort of seems like kind of a weird thing. It seems like, at least for the moment, and everything can change, that it's meant to be sort of a way for Microsoft to keep themselves in the minds of developers, and it's sort of run as a community service to developers all over the world. That seems to be a focus for Microsoft lately. So I hope it's not going away. They have a very robust education program. So if you go to education.github.com, there's a bunch of benefits and other things. With that said, anything that's free could be yanked away at any moment. Before GitHub Actions existed, I used to use a service called Worker. They got bought by Oracle and then it died a very slow death. And that wasn't a lot of fun. I think GitHub at the moment is very popular and very successful, and they're owned by a very wealthy company. They're not likely to go away tomorrow. Building something on a startup would be a little bit more fragile and a little bit more nerve-wracking. I think it's reliable, but yeah, don't put all your eggs in one basket, I guess would be my advice.
Exactly, and I think that actually answers the second question in there as well. So very quickly, and I'm going to be very selfish here and ask a question I want to ask. How much training do you give students? Because I'm assuming when they come to you, they've never used anything like this. So how much training do you actually give them? And how much time do you spend on sort of teaching them these sorts of skills?
It's surprisingly little. So last year, due to some snafus with organizing and not being able to run our workshops in the first week, we just uploaded a sort of a collection of videos that were less than an hour in length, just sort of demoing the process, and said, this is how you do it, and then said, now you have to do it. We then provided a lot of support during the subsequent tutorials and workshops, and that was helpful. So basically, you can expect more questions early on, and then they sort of taper off throughout the course of the semester. But I find what works really well is if you require students to use this to turn in their work, and they don't have an alternative option, they start to figure it out pretty quickly. I will also say we use RStudio, which has a nice sort of simple graphical user interface for Git, which makes the process a bit easier, so we're not having to teach sort of archaic command line things to the students. In the past, I've tried to teach that. It's been moderately successful, but most students just opt to use the graphical user interface because it's easier. So that's what we opt for now.
Great, thank you very much once again. And I think it's now time to hand back to Jotham.
Thank you ever so much, Colin. That was very interesting indeed, although I must say I am one for arcane command line interfaces myself.